My name is Nosipho Moloto. I'm a research professor and director of Arua Center of Excellence in Materials, Energy, and Nanotechnology. I am a chemist by training as well as a nanotechnologist. So the type of chemistry that I do is inorganic chemistry, and this is a study of metals specifically, how metals actually, what is the chemistry of metals and how they interact with matter and the sort of products that you get from that interaction. So in terms of nanotechnology, I actually use my training as an inorganic chemist to develop materials that have that inorganic chemistry influence, and then we use them for various applications. From medical applications, for example, we are making a wound dressing. In this wound dressing, it's silver nanoparticles that have antimicrobial and antibacterial properties, and they are embedded in a scaffolding that is used to absorb wound exudates. So once it absorbs it, then and the silver gets to work on the wound heals faster than a normal wound dressing. We then also use our materials for various applications. For example, in energy, produce hydrogen gas. Hydrogen can fuel cars. You can use hydrogen actually to also have a fuel cell and electrify a building. We also use our materials to actually clean water. By using the sun, you can kill bacteria, as well as we can use it in membranes where we make sure that the membranes don't get blocked. And there are many applications that we work in with our group. We look at sensors. We want to make sure that we can produce cheap sensors so that we can prevent, shack-to-shack fires. We're trying to design very cheap sensors. So chemistry is known as a central science, mainly because it's quite central. Once you have a degree in chemistry, you can do many fields. You can work as a technician in a laboratory. You can work in quality control for products. You can then also branch into actually data science, because you deal with a lot of data, so you have experience in doing data. If you continue on to study research at master's and PhD level, then you can go to any field that is research intensive. From being a researcher at a research institution or mines for that matter, you can also be working in mines. And these days you can even do AI, and therefore you can use AI to actually simplify or amplify chemical processes. So there are many fields that you can get into. So in terms of, since you're a nanotechnologist, in fact, we belong to material science, which is actually a field in the interface of chemistry, physics, biology, and engineering. So we work a lot with engineers. We work with all types of engineers. Chemical engineers are the easiest to work with because from chemistry to chemical engineering is just one process up. You're trying to scale up what you do in chemistry, basically. So they will help with what sort of parameters do you need to scale up, what sort of processes do you need to follow to make a large plant. Then I also in my field work with a lot of electrical engineering people, because we do solar cells, we look at batteries, we can improve the oil used in transformers using nanomaterials. So I have a lot of collaboration with people who are working in electrical engineering. I was born in Kwamashu in Durban. It's a township in Durban. So yes, so growing up, I grew up at my granny's house with a lot of cousins, and my granny had only girl kids, and therefore she valued empowering girls. So this is what I tell the girls, that we are blessed with, paying attention to detail. It's almost like a given, gift. And STEM requires somebody who actually cares about the detail. I think we have a lot to contribute. So I would say to a high schooler or a young kid that do follow that. It's actually a great career. Very fulfilling because it's all about life. and how we as humans and other species interact with life.